Hey 7th grade, this is video 1 of the 12-2, 12-3, 12-4 condensed lesson, even though we are going to still take 2 days to cover it. The first video is going to recap what 12-2 has to say in notes, so if you want to follow along you can. If you want to follow along with your textbook or online book, we're going to be doing some examples from there as well. So the first thing that the first point I want to make for you guys is that histograms are not the same thing as bar charts, although they are often misunderstood that way. A histogram looks similar to a bar chart. It's a graph that is used to display data from a frequency table, and each bar represents an interval of data. The height of each bar shows the frequency, or how often, how much that data happens within the interval. And in this case, what makes it different is that from a bar chart is that there are no gaps between the bars. The bars are the same width because they're representing equal intervals. The frequency of an interval is the number of data values in that interval. A frequency table groups the set of data values into intervals and shows the frequency for each interval. So to give you a better idea of what that is, that's going to be our first example here in just a moment. Intervals do not overlap or have gaps, although there could be zero values within an interval itself. So the only time you'll ever see an actual gap in a histogram is if there is an interval of data in which no data values fall. So to kind of give you a visual of the difference between histograms and bar charts, both of them use bars, and the y-axis shows frequency, or how often something happens within that category. But a histogram shows numerical data, and there's no gaps between the bars. Bar charts show categorical data, and they do have gaps between bars. So for example, if you're trying to find how many people's favorite colors are blue, purple, or green, that would be a bar chart. But if you're looking for scores or temperatures, anything that's numerical, that's when you would use a histogram. So for Got It 1, it seems pretty lengthy. It takes up an entire page, but the point of this example is just to get you to understand how frequency tables work, and it also shows that you might not have the same histogram as somebody else, but there are better ways to show it than others. So here we have, from Got It 1, I did alter it a bit. The number of home runs by the batters in a local home run derby are listed below. So here it is, and they want us to create a frequency table. So in order to create a histogram, you have to start with looking at frequencies. So here we have 14 data values, and we want to split these data values into equal intervals the best we can. The values range. The lowest value is 2, the highest is 17. So that covers 16 different data values. So I like to start by observing my data, seeing how spread out it is, and that helps me decide how many intervals I want. So note, choose a number of intervals that would display your data in a useful way. You wouldn't want to only choose 2 intervals because then you'd only have 2 bars, and that doesn't really tell you much about your data. You also don't want, in this case, 8 intervals or more when you only have 14 data values. So I set up 2 different frequency tables. I decided to try 4 intervals and 5 intervals. It doesn't matter where you start for your intervals. You just want to make sure the intervals are of the same width. So in this case, my lowest is 2, my highest is 17, so it works out nicely if I split it into intervals of 4. 4 intervals of 4 data values. And you'll notice that the data is spread out pretty nicely. Okay, I have a note here, or a tip: start with the smallest data value if you can, or as close to it as possible. If we were doing 4 intervals and we started with 0, then we'd end up having 5 different sections instead of 4, which is fine. But it's not really going to stay to the consistency we're looking for here. Here we have a 5 interval table. So we went from 0 to 4, 5 to 9. So this ends up being 4 bars of 5 intervals. And so you'll notice this one, the numbers are slightly different. They don't look as uniform, but that's okay. Now, while you do have options, some are better than others. What if we did a 5 interval table starting with the interval 2 to 6 instead of 0 to 4? If we do that, again, we end up with just 4 bars, but you'll notice that that last bar seems pretty pointless because we went way above our highest value that we actually were given in the table itself. So just kind of look through this and it'll help give you some reassurance. Am I choosing the right intervals? Am I not? Again, there's not one perfect answer, but there are better answers. So that's going to help us get into how to actually create a histogram, which you will be doing on the worksheet. A note, numerical data and frequency. When you make your table values or your frequency table, this is your interval range, or are your interval ranges. Here's how often each happen. This is going to become your x-axis and your y-axis, just like graphing with a table of values. If you start at 0, you want your first bar to go right up against the y-axis. If you're starting with something like 2 or 175, you would actually put a break in the graph. And you want to make sure you title. Notice there's no gaps between the bars. You're going to put your interval ranges along the bottom and your frequency across the y-axis here. So for got it 2, the finish times in seconds for a race are shown below. What is a histogram that represents the data? So I organized all my data here. It might be useful to organize them in order or reorder them, or I just went straight to a frequency table. I noticed that my values ranged from 80 to 105, covering 26 values. So I chose to do 4 intervals of 27 because that would give me 28 total values I'm grouping between, and it's very close to the 26 total I have. So then I also decided to start with 80 since that's my lowest values, which would take me to 106, which is very close to my highest value. And then I start tallying, or you can use new numbers instead. And there's my interval data here, 4, 4, 3, and 2. So when I convert that into an actual frequency table, since I'm not starting with 0, I put a break in my graph. Notice my bars are basically the same size. Use your imagination, they are the same size. I list my intervals here in order, no gaps. I titled finishing times. This title is usually, if you just put frequency, that takes care of every y-axis title. And I go from, well, my lowest is a 2, but I don't want to put a gap here just to go up to 4. So I go up to 4. I did some nice spacing so that I could see my bars real nicely. You don't have to shade in your bars. I just like how it looks a little bit better, makes the bars stand out better. This note here, actually both these notes here I just addressed while going through the problem. So that wraps up got it 2. Okay. This part of the notes here is more something if we were in class and we had more time we would focus on. So just to skim through it, describing based off of their shapes. If you have something where the bars are all very similar in size based off frequency, that would be something called uniform because they all have some type of uniformity. If they have a peak in the middle, or sometimes you might have the 2 peaks on the edges and then it goes down. But if you have any type of symmetry, that would be symmetric data. And skewed. If there's no constant trend or if there's no symmetric trend at all, it would just be skewed data. And notice here we have a gap. That doesn't mean all of a sudden we changed from a histogram to a bar chart. That just means that data value interval would actually have no data values within it. So you won't need to be doing any of that in this assignment, but it is something you want to be familiar with in future classes. So example 3, our final example here, I did change it. It's not the same as got it 3, so if you're following along, this is different. This example, we're actually going to practice interpreting a histogram. So it's already given to us and we're going to answer questions for it. So this histogram shows the amount of money that 50 customers spent in a supermarket. It does start at 0, so we're up against the y-axis. We have nice even intervals, 0 to 19, 20 to 39, and so on. This represents the amount spent, and this tells you how many customers. So notice they didn't just put frequency here. They helped give you a little more information by actually titling it the number of customers. So this would be, we're going by 2s, even though I only labeled every other line here. So this would be at 9. So 9 customers spent between $0 and $19 is what this is showing us. So for part A, what is the upper limit on the amount of money that any customer spent? Well, the highest value they show us in the graph goes up to 99. So that is now not 100% certain, but that's the most that they could have spent based off of our graph. It may have been $98, but based off of the rule that our intervals have to be equal, then it ends up ending at 99. So that would be our upper limit. And don't forget to label. Part B, which interval represents the greatest number of customers? Well, that's just going to be our biggest bar. So 20 to 39. Okay. Now, since it just asks for interval, I don't have to put the dollar signs, but if you want to make sure you don't get into bad habits, you can put the dollar signs there. You will not get marked off for labeling when you don't have to. And part C, how many customers spent less than $20? Well, that's what we just talked about at the beginning. This bar here goes up to 9. It represents $0 to $19. So only 9 customers out of all of them. Okay, and then I did add a little bit extra here, but again, this is something that because we're condensing this lesson, it's not going to be assessed, or I guess not assessed, but on this worksheet. How would you describe the shape of the data? Honestly, I would probably accept either symmetric or skewed depending on your argument. This bar here is the only one that really throws it off being somewhat symmetrical. But if you're looking at the whole trend, the peak's not really in the middle. It's kind of shifted to the side. So that's why some might argue it's more skewed. So especially next year in Algebra 2, we're going to learn that there might not be one answer for that as long as you can provide a valid argument. So it's something to think about, but again, it's extra for this year. So don't worry about it if you'd like to focus on just creating and interpreting histograms. And that wraps up 12-2 and the end of video 1.